In this video, you will learn how to identify similar figures. This is notes. Make sure to write it down. You don't need to draw the dinosaurs. So what are similar figures? Similar figures have the same shape, but they can be a different size. So they're either scaled up or scaled down, but they're the same shape. They should look the same, just smaller or larger. That includes being able to flip or rotate your image. So it's the same shape even if you've moved it around a bit. However, if you've stretched it, then it's no longer similar. So these dinosaurs, this one has been stretched out longer than the other one, so they are no longer similar. So how do we figure out if figures are actually similar or if they just look like they're similar? In order to do that, we need to decide which sides are corresponding. So first, figure out if the figure has been rotated at all. So this one has, but I can tell by looking at it that the shortest side is A, and the shortest side on this triangle over here would then also match with A. So I'm going to label that A prime, which is an A with a little tick mark up in the corner. Then I'm going to do the longest side. So in the original, that's C. And in the possible copy, that's here. And I'll label that one C prime. C prime. And then the medium, the middle length, is B, so I'll label that B prime. So if these are similar, these are the corresponding side lengths. So now we know which sides are corresponding. We can compare the ratio. So we're going to make a ratio for A to A prime, and that's going to be 4 to 2. We'll make a ratio for B to B prime, and that is 6 to 3. And we'll make a ratio for C to C prime, and that's 8 to 4. Now you may already be able to see that the side lengths on the second triangle, the smaller one, are half of the side lengths on the first one. And so that means that they are similar. But we can go ahead and prove it mathematically anyways. So what we want to know is, does 4 halves equal 6 thirds? And yes, because they are both equivalent to 2. And 2 is equal to 2. And we can do the same thing with the other pair. So is 6 thirds equal to 8 fourths? Yes, because they are both equal to 2. So we can say yes, they are similar. All right, let's do another example. Copy down these figures and try and prove whether or not they are similar. Unpause when you're done. Okay, so the first thing you should do when deciding if figures are similar is figure out if it's even reasonable that they could be. These are both rectangles, they look like they might be similar, so let's go ahead and test. Next, we decide which sides are corresponding. So the 3 and the 5, those are the short sides, so those are corresponding. And the 11 and the 7, those are the long sides, so those ones are corresponding as well. So I'll set up my ratios. 3 to 5 for the short sides. Is that equivalent to 7 to 11? So there's no obvious relationship here, so I'm going to test them by dividing. I'm going to see what this ratio is equivalent to if we divide numerator by denominator. So I'll do 3 divided by 5. 3 doesn't go into 5, so I'll add a decimal. 3 does go into 30 exactly 6 times. Okay, so this ratio is equivalent to 0.6. I'll do the same thing for the other one. I'll do 7 divided by 11. Well, 11 doesn't go into 7 evenly, but it does go into 70, 6 times. 6 times 11 is 66, so it's not going in perfectly. I'll bring down another 0. 11 goes into 43 times, giving me 33. I subtract, I get a 7. Looks like it's going to repeat now. That'll give me another 6. So the ratios are very similar, but they are not the same. 0.6 is not close enough to 0.63. So no, these are not similar. All right, let's do another example. Are these figures similar? Pause and prove it. Okay, now that you've tried this on your own, this is the way I would do it. So first, I'm going to match up my corresponding sides, short with short, long with long, and then the slanty sides with each other. And since both of them are the same, I only need to test one of those 3 sides. So the question is 15 over 10 equivalent to 30 over 20 and 39 over 26? So your first check is to see if they can be simplified. So the first one can be divided by 5, numerator and denominator, leaving you with 3 halves. The second one can too, dividing by 10, leaving you also with 3 halves. That's promising. The third one looks different, but I do notice that they are both divisible by 13, also leaving me with 3 halves. So that means that, yes, they are similar. Now we're going to go on to the problem set. So here's your problem set. We'll go over this on Wednesday. I've given you 6 figures, and I want you to try and decide if any of them are similar. Is A similar to B? Is A similar to C? Find all the pairs that are similar and prove it for each one. You do not need to prove it for the ones that are obviously not similar.